Good morning, good afternoon. This is Integrated Math 2. Today we're going to be talking about using sine inverse, cosine inverse, and tangent inverse to find a missing angle. Last week we did a lot of looking for a missing side. This week we're looking for the missing angle. So we're going to start just by looking at these equations and kind of thinking about what they represent. So it says, using your calculator, estimate to the nearest degree the measure of each acute angle B for each of the following trig functions. So what that means is that you might take out your calculator and you might test out different values. So you might say, well, what's the sine of 10? Is it equal to 3 divided by 4, which is 0.75, right? And you would take out your calculator and you would do that. So let's go ahead. So if you had a calculator, and later on I'll show you how to do all this math without a calculator, you might go to your calculator, you would make sure that the mode it's in is in degree mode, because that's how we're doing our answers, is in degree mode. And you would say, well, what is the sine of 10 degrees? And is it equal to 0.75? And we notice it's not, so let's try something different. Let's try the sine, let's say 50. Okay, is it equal to that? Oh, 0.76 is pretty close. Maybe something like a little less. So let's say sine 45. Okay, is that equal? Oh, that's a little too high. That's 70 cents. We're looking for 75 cents. And then sine, let's say like halfway, 48 degrees. Okay. Oh, that would maybe get a little closer. Maybe sine of 49 degrees. Okay. Bingo, we're on it. So we could estimate our answer using the calculator that way. Okay, that's one way we could do it. Okay, ignore that for a second. Now, I want you to really understand where this comes from. So what kind of triangles, think to yourself, what kind of triangles are we thinking about with this work? We're thinking about a right triangle. So if we were to visualize the right triangle for this problem, and we'll just do this. If we were to visualize the right triangle for this problem, the right triangle might look like this. Let's put this side over here, where we have a right angle, it makes a triangle, and it's a sine. So we know that sine is our SOHCAHTOA. So if that's our angle, we're looking at the opposite side and the hypotenuse side, right? And we know that since this is set up like a fraction, our opposite side, okay, is going to be 3, and our hypotenuse side is going to be 4. So 3 over 4. So this equation actually is going to help us solve for this angle down here. Okay? It's going to help us solve. So we actually figured out that this angle, since, okay, so we could say since the sine of 49 I really have a tough time with this symbol because we really shouldn't be using an equal sign, we could say is about equal to 0.75 or 3/4, the angle in this triangle is 49 degrees. Okay? And that's how we could solve it. It does say go back and use this table on 465. So if we look at 465, I put the table here, and we look at 49. Okay, yep, the sine at 49, do you guys see that, is 0.75, okay? All right, so this is where we're going to get into how to solve this without using guess and check. We're going to talk about what button, okay, I'll give you guys a hint right here. What button do we use to solve it? But let's just look at these other two problems to make sure we're in it the right way. So I'm going to put these on a new page. New page. All right, so for both of these, let's visualize our triangles. Let's start with our first one, cosine. So our triangle might look like this, and this is a cosine problem. Ah! So SOHCAHTOA, right? So A is, 1 is A, okay, and 2 is H. So if this is our angle down here, if this is our B, okay? A is 1, adjacent is 1, that's the next to side, and the hypotenuse is 2. And we're trying to figure out when is the cosine equal to 1/2. Cosine of what is equal to 1/2 or 0.5, okay? So let's say, let's just do some some guess and check, right? So you might say cosine, let's start at 45. Cosine of 45, and we get 0.7. That's not it. So let's try something different. Let's try cosine 40. Let's try 40. Is that closer? No, that's kind of going the wrong way. That's 0.76. We're trying to go lower. Let's do it the other direction. Let's say cosine less than, well, no, so this was less than 45. So let's do cosine, let's say 50. 50 more than that, okay? Oh, that's going in the right direction. We were at 70 cents. Now we're at 7.76 cents. Let's keep going. So let's say cosine of, let's say 60. 0.5 on the nose. We got it, okay? So we could use guess and check to figure out that yes, in this angle, okay, for this statement to be true, this has to be 60 degrees. So this angle is 60 degrees, okay? Okay, so we could say since, okay, cosine of 60 is equal to 0.5 or 1/2, the angle B is 60 degrees. Boom, got it done. All right. So let's do our last one. Our last one is a tangent problem. So you might want to pause the video and really try to think about, what would this triangle look like? How could I label it? Right. So just think about that for a second. So we notice that usually when we talk about tangent is the opposite over the adjacent. Well, there's no adjacent here, so what we have to do is think, well, 2 can be a fraction if you put it under 1. So if we have, this is our angle here, this is our B that we're so concerned about. Our opposite side is 2, and I drew this backwards, and our adjacent side is 1. You see how I drew that backwards? Like it looks a little silly, right? Maybe our triangle should look a little more like this, right? A little different, because if this is 2 and this is 1, clearly that should be the bigger side. So that's what we have, all right? So we want to think about, well, how can I want to use my triangle, or how can I use my calculator to figure out, well, tangent of 2 over 1. So let's just test some values. So we get tangent, and let's start with 45. Tangent of 45, we get 1. That's not it. So let's try something bigger. So maybe tangent of 60. Let's try it. Oh, that's heading in the right direction. Tangent of 60 is 1.73. That's almost 2, not quite 2. Let's go a little higher. So let's say tangent, let's say 65. Okay. Oh, that's a little too high. That's too much. A little too high. So let's try something different. Let's say tangent of 62. Let's try that. Okay, getting closer. Tangent of 64. 2.05, that's pretty close. Maybe tangent of 63. It's not exact, is it? Yeah, so it's somewhere between 63 and 64 degrees, right? So we know B is going to be between, let's put this right here. B is between, okay, B is between 63 and 64 degrees. Now, we're really fortunate we have a calculator, so it's real easy to say, well, let's test the halfway point. Let's say tangent 63.5, okay? And it's pretty close. Pretty close. I would say that's what we could say our answer is. So we could say B, so since tangent of 63.5 is equal to 0.5, what was it, 0.5000, what was it, point what? What was it, 0.56, yeah. We can estimate that B is 63.5 degrees. Okay? All right. Now we did a whole lot of guess and check to do this, all right? But that's one way that we could do this. Now, if you're trying to follow along, you're saying, I really would love to do this, but I don't have a calculator. It's cool because you can just go to your calculator, right? And if you go to Google and you type in equals tangent of 63.5 degrees, see how I'm typing this in? All right, it does it, but you have to put degrees in there, okay? So if you're like, oh, I don't have a calculator at home, like it's no big thing, right? Because you can just use Google to do all these estimates. So that would be for that, you could do it there, and then, I mean, you could do the same thing here with the cosine 60. So you could go back to Google, and we could do cosine of 60 degrees. You have to put degrees in there, or else they're going to think it's a radian, which is something different, which I guess you guys will do next year. Send to the current page, yeah. Okay, so that's how we could kind of show it that way. And you could just guess and check, just changing those numbers there. All right, so we're going to wrap this up. We did a lot of just guessing and checking to solve equations. We had 3 equations here. We used guess and check to solve them. You also could solve them using a table similar to this by just looking for those ratios in the table, looking for where is cosine equal to 0.5, okay, where is tangent equal to 2, all right, which is right here in 63.5, right? But the main idea is that you can use guess and check to solve. In the next video, we're going to talk about this shortcut, this shortcut. I'm showing you right here. Here's the hint on how to do it.